Hello everyone. In this lecture, we are going to solve some simple problems related to 1H-NMR spectroscopy, which mainly deals with chemical shift value, the splitting pattern, and predicting the chemical shift also. And also we will deal with some of the sketching of NMR spectra of simple compounds. We will see one by one. Before we go for this, let us quickly brush up our memory regarding the chemical shift values for different types of protons that are present in organic system. As we know that it is the primary methyl, the value of which lies between 0.7 to 1.3, secondary alkyl 1.2 to 1.4, tertiary alkyl 1.4 to 1.7. This is allylic system, primary allylic 1.6 to 2.6. This is methyl ketone 2.1 to 2.5. This is methyl group. We can say it is a methyl ketone having electron withdrawing or electronegative oxygen, and hence its value will be slightly higher, 2.1 to 2.6. This is methyl attached to nitrile or cyanide, whose value falls between 2.1 to 3. This is aromatic methyl 2.3 to 2.7. This is acetylenic 1.7 to 2.7. This is proton attached to amine 2.2 to 2.9. This is proton attached to, not directly attached to sulfur, but proton attached to carbon. The carbon in turn is attached to sulfur. We can call it as sulfides, whose value fall between 2 to 3. And these are some of the halogens. Hydrogen attached to carbon containing iodo 2.4, bromo 2.7 to 4.1, chloro it is 3.1 to 4.1. This is fluoro, which is the most electronegative, and hence we can expect very high chemical shift value 4.2 to 4.8. This is ether linkage 3.2 to 3.8. This is ester 3.5 to 4.8. If the hydrogen is attached to nitro group, then it is 4.1 to 4.3. This is alkenic or vinylic 4.5 to 6.5. If the proton is directly attached to aromatic system or benzene, it is 6.5 to 8. Don't get confused between this and this. This is proton attached to benzene directly, whereas this is proton attached to carbon. That carbon is attached to aromatic system, and hence the value is less. This is directly attached proton. Because of the high ring current, there will be more deshielding, and hence the value fall between 6.5 to 8. This is aldehydic proton 9 to 10. If the proton is directly attached to sulfur, that is thiol, the value falls between 1 to 5. If the hydrogen is attached to nitrogen, 1 to 5. If the hydrogen is attached to oxygen, 1 to 5. Usually, if the proton is attached to oxygen, nitrogen, or sulfur, then the peaks will be usually broad or sometimes maybe absent. Then it is phenolic 4 to 7. If the proton is attached to amide nitrogen, then it is 5 to 9. The last is carboxylic acid, which is 11 to 12. So these are some of the chemical shift values for different types of protons present in the organic system. Now we will be moving to the problems on 1H-NMR. We have got two exercises here, and this is exercise 1, some of the simplest problems. The first problem is predict the number of signals, chemical shift, and multiplicity for the following compound. So what he's asking is, we have to predict how many different types of peaks are there, which is given by number of signals. We have to predict the chemical shift values and also the multiplicity. Multiplicity refers to spin-spin coupling or spin-spin splitting. This is the problem or the compound that he has given. This is isopropyl chloride. As we can see here, there are two kinds of peaks or two different types of protons, and hence we can expect two different types of signals. One proton is attached to this carbon, and the carbon is attached to chloro, and hence you can expect somewhat deshielding, whereas you can think that there are two methyl groups, and hence you must expect two different types of signals, but the answer is no, because both the methyl groups are present in the same chemical environment. See here, for this also the neighbor is H, for this also the neighbor is H, that is CH, and both have got in common Cl. That's why these two protons, that is CH3 protons, are coming in the same environment. Hence we can expect a single peak, and hence we can expect single chemical shift value, whereas this proton which is attached to carbon and the direct linkage with the chloro, we can expect another proton. So the number of signals here are 2. Next, we have to predict the chemical shift and multiplicity. Okay, when we talk about the chemical shift, we can see that CH3, it is alkyl primary. Primary alkyl, the value should be usually 0.2 7 to 1. Because there is a chloro group, we know that chloro is a electron withdrawing group, and hence the value of this methyl groups, these two methyl groups, will be somewhat more when compared to the usual alkyl primary, and hence the expected value will be slightly more than the regular primary alkyl, and hence the value is 1.71 instead of 1. The other one, if the proton is attached to chloro directly, then the value fall between 3.3 to 3.7. We can say that the average is 3.5. So for this proton, you can expect the value of 3.5. For this proton, you can expect the value of 1.7. So this is about the chemical shift. Next, we have to predict the multiplicity. For predicting the multiplicity, we must use n plus 1 rule. What does the n plus 1 rule says? N refers to number of neighboring protons. Here, first we will see this proton CH3, the adjacent or the neighbor is CH. For this also the neighbor is H. So 1 plus 1, here the neighboring proton is 1. 1 plus 1 is 2. That's why this CH3 will appear as a doublet in the 1H NMR spectrum, whereas this CH has got the neighboring 3. This also there is neighbor 3. 3 plus 3 is 6. N plus 1, there are 6 neighboring protons. 6 plus 1, that is 7. You are going to get a septet. Hence the among the two signals, one will be a septet, another one will be a doublet. That is what is shown here. For this isopropyl chloride, there are two types of signals. The value for one is 3.5. The value for another one is 1.71. One appears as a septet, another one appears as a doublet. Here we have to make use of n plus 1 formula. Fine, for this compound there is no double bond, but in case if the compound has a double bond, then we must calculate the double bond equivalent or relative abundance, or in short we call it as index of hydrogen deficiency. So calculate relative abundance or DBE, double bond equivalence, or index of hydrogen deficiency. We have to make use of this formula, molecular formula CaHbNcOD. We have to remember this. And the formula for relative abundance is A plus 1 plus A minus B by 2, where A is number of carbon atoms, C is number of nitrogen atoms, B is number of hydrogen atoms. Since there is no D here, you can easily omit this oxygen. So A, in this compound, how many carbons are there? There are 3 carbons, 1, 2, 3. Substitute 3 here, 3 plus 1 plus C. We do not, C is nitrogen. We do not have nitrogen in this compound, so 0 minus B. B is hydrogen. 3 plus 3 is 6, 6 plus 1 7, 0 minus 7 by 2. So 3 plus 1 is 4, 7 by 2 is 3.5 minus. So 4 minus 3.5 is a fraction, 0.5. This indicates that there is no unsaturation in the compound. If at all you get any unsaturation in the compound, it means that the compound does not have any unsaturation. Why we need to have double bond equivalence, why we have to calculate, or what is the significance of calculating DBE is that we can know how many number of unsaturations are there, and also we can know if at all there is any ring system present in the compound, that we can easily predict by using this double bond equivalence. We will move to the next set of question. So he says, predict the multiplicities of the signals in the proton NMR spectra of. Here he has given only the names 1,3-dichloropropane. This is the compound, this is the compound. In the previous question he had asked by giving a structure, but here he has given the name of the compound and he is asking predict the multiplicities. How many types of signals we are going to get? That we will see. If at all there is a name given, then we have to convert that name into structure. So here the base is propane. Propane means there should be 3 carbon atoms, 1, 2, 3. Then number it 1, 2 and 3. He says at 1 and 3rd position there will be 2 chloro groups. So attach 1 chloro, attach another chloro. This becomes 1,3-dichloropropane. Now we have to predict the multiplicity pattern. How we are going to get? So start from this side. This is CH2. This is having the neighbor CH2. Look at this CH2. This is also having the neighbor CH2. Both these CH2 groups have got same chemical environment because Cl is attached to this, Cl is attached to this. Both have got the neighbor CH2, and hence these 2 protons are going to appear as one peak. So this CH2 will appear as another peak. So for this compound 1,3-dichloropropane, you can expect two types of signals. He's asking only the multiplicities. We have to predict only the multiplicities, nothing else. The next question is 1133 tetrachloropropane. Again, the base here is propane, right? 3 carbon atoms. Tetrachloro means there are 4 chloro, where 1133. That means at first position we have to number this 1, 2, 3. At first position attach 2 chloro. At third position again attach 2 chloro. This is going to be the structure. Now we have to predict the multiplicity for this, or we have to predict the types of signals. Now we will start from this side. This CH has got the neighbor CH2. This CH has also got the neighbor CH2. So n plus 1, n is 2 here, 2 plus 1 is 3. So this is going to appear as, this both will appear as triplet here. Now we will coming for this carbon. This has got CH2, whereas the neighbor is here 1, here 1. 1, 1, 1 is 2. N is 2 here, so 2 plus 1 is 3. That's why you are going to get triplet, and we are going to have two types of signals. These two will give one signal, this one will give another signal. You are going to get two types of signals. Because he is asking multiplicities, we can also predict the multiplicity pattern for this. This both has got CH2, 2 plus 1 is 3. So this is will appear as triplet, and coming for this, here there is 2, here there is 2. That is 4, 4 plus 1 is 5. That means we are going to get pentate here. Coming to another problem, diisopropyl ether. Diisopropyl ether, ether linkage is RO R dash. So there should be O in the middle. Isopropyl group, this is isopropyl group, CH with 2 CH3, CH with 2 CH3, diisopropyl. Now we have to predict the multiplicity for this. But before that, we have to see how many different types of signals we are going to get. So this molecule is symmetric in nature. So whatever you predict for the LHS, the same will be for the RHS. We will see what we will get for LHS. So this one is H, it has got 2 CH3s. This one is H, this has got 2 CH3s. So it is a perfect symmetric molecule. Now consider this CH3 twice. This CH3 twice has got the neighbor only one H. One H is 1 plus 1, that is 2. You're going to get a doublet for this. You're going to get a doublet for this. Now coming to this H has got 6 hydrogens. CH3 twice, that is 6 hydrogens. 6 plus 1 is 7. You're going to get a septet for this. So this CH will appear as septet, whereas CH3 twice will appear as doublet. So whatever you predicted for LHS, the same thing holds good for the RHS also. Here this H will appear as septet, whereas this H will appear as doublet. The next problem, predict the number of signals, chemical shift, and multiplicity for the following compound. So this is the compound that they have given here. And now we have to see how many number of signals we are going to rate. That means how many different types of protons are present in this molecule. We will start counting. This is methoxy. This is one type. And you will blindly say that there are 4 protons. All the 4 protons are aromatic. You will say only one signal. But in depth, we have to observe carefully. These two protons have got the neighbor OCH3. These two protons have got the neighbor CO. If there is OCH3, no doubt there will be inductive effect because of the electronegative oxygen. Here, this side, these two protons will have anisotropic effect of this carbonyl group as well as the electronegativity of this oxygen. And hence, these two protons will appear at more delta value, that means more de-shielded compared to these two protons. Whereas this CH2, CH3, they both are present in the different environment. This CH2 has got CO, CH3, it has got the neighbor only CH2. This side it has not got anything. So there will be 5 types of signals. 1, 2, 3, 4, 5. That is what is shown in this structure here in different colors. This methoxy 1, we'll say it as HA and HB. These two 1, these two 1. CH2 is different, CH3 is different. So number of signals we have predicted it as 5. Now we have to predict the chemical shift values. What will be the chemical shift value? We know that this is ether linkage. Ether will be around 3 to 4. So it is 3.8. And what will be the multiplicity for this? This CH3 has not got any neighboring proton. Any neighboring proton it has not got means n is 0. So 0 plus 1 is 1, and hence the signal will be appearing as a singlet. Now coming to this has got the neighbor H, this has got the neighbor H. So neighbor, there is only one H, 1 plus 1 is 2, that means you are going to get a doublet. In short, we will represent it as D. Here singlet, we shortly represent it as S. This also has got a neighboring only one proton, HH, that's why this also will appear as a doublet. Then coming to this ethyl type, so CH2, it has got the neighbor CH3, 3 plus 1 is 4, you are going to get a quartet. And for this, the neighbor is CH2, 2 plus 1 is 3, that is, you are going to get as a triplet. So we explained the chemical shift value. This will have the chemical shift value of 3.8 because of the ether type. And this is aromatic. We must remember aromatic is 6.5 to 8. But we have to make the distinction here that the left hand side will have lesser value because this methoxy is electron releasing group, whereas this carbonyl is electron withdrawing group. So this side you expect more shielding, whereas this side you expect more deshielding, and hence delta value will be less, whereas here the delta value will be slightly more when compared to Hb protons. This CH2, it is acting as a methyl ketone, so the value will be 2.85, and this is primary alkyl. You cannot have the value 1 for primary alkyl for the reason that it has got a carbonyl group. There will be certainly a influence of anisotropic effect on this methyl also, and hence there will be a slight increase in the delta value of this primary alkyl group. So this is how you have to solve the problems. The fourth question, predict the splitting pattern of the following. We have to predict the splitting pattern. He has given the question CH3O, CH2, CH2, Cl. We have to first check how many different types of protons we are going to get. We shall start from this side. This CH3 has got not any neighbor, so there will be only a singlet here, one peak. This CH2 has got neighbor O this side, and CH2 has another neighbor. So CH2 this side no protons, this side there is 2. That means 2 plus 1 3. So you can expect a triplet for this. For this also, one side is Cl, another side is CH2. Definitely you will expect triplet. So singlet, triplet, triplet. 3 types of signals: singlet, triplet, triplet. The next problem, Br, CH2, 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 CH3. That is 1,3 dibromopropane. We have to see how many different signals we are going to get. This is a symmetric molecule. LHS is equal to RHS. This CH2 has got the neighbor, another CH2, 2 plus 1 is 3. So you are going to get a triplet here. For this, the neighbor will be CH2 and CH2. That means there are 4 protons. 4 plus 1 is 5. So obviously you are going to get a quintet for this. That is what is shown here. Quintet for the middle proton, the triplet for the terminal protons. This also triplet, this also triplet. This is another molecule. Just by looking at this molecule, one may say that this will appear as a singlet, this also will appear as a singlet. But you must observe carefully that this is the derivative of methane, and hence you have to split the structure and write like this: CH, Br, Br, CH3, dibromomethyl methane. Now we have to check, this is Br, Br, this will not involve any NMRs, whereas these 2 protons will show NMR. So this H has got the neighbor CH3. So CH3, 3 plus 1 is 4, that is quartet, and this proton has got the neighbor only 1 plus 1 is 2, that is doublet. Another problem, CH3, CH2O, CO, CH, CH3, CH3. First let us see how many different types of signals are there. CH3 1, CH2 1, CH1, these 2 are present in the same atmosphere 1. So you are going to get 4 different types of protons here. Now let us see the splitting pattern. This CH3 has got the neighbor 2, 2 plus 1 is 3, so this will appear as a triplet. Now let us see for this, CH2 has got the neighbor CH3, 3 plus 1 is 4, so this is as a quartet. Triplet quartet is a characteristic feature of the methyl. Coming to this is isopropyl. Always remember, for isopropyl there will be doublet and septet, or doublet and multiplet. That is the characteristic feature of the isopropyl group. Here this CH, H has got 6 protons, 6 plus 1 is 7, so this H will appear as a septet, whereas these three methyl groups has got only one proton as neighbor. 1 plus 1 is 2, that is doublet. So triplet, quartet, septet, doublet. Triplet, quartet, as I said earlier, it is the characteristic feature of an ethyl group. Septet and doublet is the characteristic feature of an isopropyl group. So this is self-studied problem solved by yourself. Predict the splitting pattern of the following. Take the screenshot of this and try to solve by yourself. If at all you get any doubt, post it in the comment section in my channel so that I can see whether you have got the correct answer or not. If at all you have got any doubt, you can clarify the doubt in the discussion forum. The next question is, draw the structures for compounds that meet these descriptions. So far, he was giving either the structure or the name of the compound, and he was asking to predict the multiplicity, splitting pattern, and types of signals or number of signals. Now, rather than that, he is giving only the molecular formula and the splitting pattern. Based on this, we have to predict the structure of the compound. Let us see what we are going to get. The first one is C2H6O. It is showing only one singlet. If such a question is asked in the examination, so what you have to do is, normally first you have to go for the calculation of DBE, that is double bond equivalent. For this compound, the double bond equivalent will be 0, indicating that this compound has not got any unsaturation. Now there is only one O and there is only one singlet in the molecule. Now we have to check what we are going to get. So the C2H6O, one singlet with just two carbons, we have to arrange in a way that we are going to get only a singlet. That means the molecule should be more or less symmetric in nature. We will see what it is. One O we will try to put in the middle. C2H6 can be easily written as CH3 and CH3. So one oxygen in the middle, CH3 on one side, CH3 on another side. So this is dimethyl ether, CH3O, CH3. Both have not got any neighboring protons, and hence the splitting will be only a singlet, and it is a symmetric molecule. So this structure best fits this formula and the description given. We will move to the next problem. C3H7Cl. It is showing one doublet and one septet. As I've already told you a short while ago, that doublet and septet is the characteristic feature of an isopropyl group. Now C3H7, it is definitely a propane system, and we are telling that the clue coming from this is an isopropyl, and hence the structure is CH3, CH, CH3, Cl. Here you can see that there is an isopropyl group and a chloro, so the compound name is isopropyl chloride. Now we will see the splitting pattern. Whatever the splitting we have to get here, it should match with this. So this CH3 and this CH3 both are same. So 6 plus 1 is 7. So this one is going to appear as a septet, whereas this has got only one neighbor. That's why it is appearing as a doublet. He's telling one doublet and one septet. Another molecule C4H8Cl2O. It is showing two triplets. So two triplets and only one oxygen. It indicates the presence of a symmetric molecule. Maybe this compound belongs to ether type. We will see what it is. So put oxygen in the middle. Two triplets. Triplet means you should have two neighboring protons. CH2, CH2 type. Now we will see. Put O in the middle. Put O in the middle. One side CH2, CH2, another side CH2, CH2. This will show triplet, triplet. This will also show triplet, triplet. There are two chlorine. Put one side, put another chlorine on the other side. This will be the resulting structure. Oxygen in the middle, LHS, CH2, CH2, Cl, RHS, CH2, CH2, Cl. So you are going to get two triplets. This one is showing triplet, this one is showing triplet. LHS is equal to RHS because it is a symmetric molecule. You are going to get two triplets. The next compound C4H8O2, it is showing one singlet, one triplet, one quartet. Now for this type of problems, you have to analyze carefully. So he's telling there are two oxygens, one singlet. One singlet means there should not be any neighboring proton. One triplet, that means there should be a CH2 neighbor. One quartet, there should be a singlet, there should be a single CH3. So triplet quartet, as I said, it is the characteristic feature of the ethyl group. So CH2, CH3. On the another side, you can have CH3 because it is giving a singlet. And in the middle, we have to substitute with the CO2. So C double bond OO. This is the ester type compound. CH3O, CO, CH2, CH3, or you can put this compound in this side, CH3COO, CH2, CH3. Now let us see if the splitting pattern is satisfied or not. For this proton, there is no neighbor and hence it is appearing as a singlet, one singlet. CH2 having neighbor CH3, 3 plus 1 is 4, it is a quartet, you are having one quartet. CH3, come to this, there is 2 proton, 2 plus 1 is 3, so you're going to get a triplet, one singlet, one triplet and quartet. The description is satisfying and hence the structure can be this. This is the next set of problem you try to solve by yourself. If at all you have got any doubt, just let me know in the discussion forum. We can solve this at the later stage. And as an instance, I have solved only one problem this side and another problem this side. Let us see what this question is. Predict the chemical shift positions for the protons in the following. So he has given the structure of the compound. You just have to predict the chemical shift values based on the different types of protons present in the molecule. While predicting the chemical shifts, please bear in mind that you have to understand what are the neighbors present in the molecule. Before that, you have to see how many different types of protons are there in the molecule. Let us see this. This is methyl acetate. This CH3, COO, CH3. This is ester. And hence it is methyl ketone type. It is showing delta of 2. Whereas this is ester. Ester is 3 to 4. We have written 3.6. And the rest you solve by yourself by taking the screenshot. Next is another problem. Here there is double bond. CH double bond CH2 alkenic is 5 to 6.5 and CH2 CH3 this is triplet and quartet, that is the characteristic feature of the ethyl group. So this will be 6, this will be 5.8, this will be 4.1 and this will be 1.3. That is how you have to predict the chemical shift positions for the rest of the compounds. The next problem, how do you explain the chemical shift data of the following compounds? So he has given these compounds and also has given the chemical shift value and you have to offer your explanation. This proton is showing delta value of 5.57 and is asking why, justify. The justification that can be given is 5.57. The value is showing that the proton could be an vinylic or alkenic. Yes, definitely this hydrogen is attached to an alkene and hence the value is 5.57. There will be an isotropic effect of this proton. It is coming in the paramagnetic shield or ring or the cone. And then this proton, it is showing the delta of 7.37, whereas this proton is showing 5.57. And we have to check why it is. This proton, it is directly attached to the benzene ring. This is aromatic system, whereas this is not, this is cyclohexene. Cyclohexene is not aromatic, whereas this is benzene and it is aromatic benzene or aromatic proton. So it is 7 to 8.5. We can clearly have the value of 7.37 and this is because of the ring current. This proton is coming in the paramagnetic shield. This is acetylene. Acetylene, it is showing very less value, 2.6. We know that it is because acetylene is linear in structure. In one direction it is showing diamagnetic and other direction it is showing paramagnetic, and this is coming in the, when it is put in the vertical position, it comes in the diamagnetic region. Because it is coming in the diamagnetic region, it is showing less chemical shift value than the alkene. Next comes this question. This CH3 attached to this cyclohexene, but what is the difference between this compound and the first compound? Here the hydrogen is attached to the alkene, whereas here hydrogen is attached to a carbon. That carbon is attached to the alkene, so it is appearing as an allylic type, allylic primary. That's why it is 1.5 to 1.8. So we have written it as 1.68. And this is the fifth one. This is toluene CH3 attached to benzene. This is methyl, aromatic methyl or methyl benzene, and hence the value is 2.32. The difference between this and the second is here hydrogen is directly attached to benzene, but here hydrogen is attached to carbon. In turn, carbon is attached to another carbon in the benzening, and hence the value is less here. There will be less ring current here. The ring current is more. That is the type of explanation that you should offer when such a question is asked in the examination. The next question, in toluene, the methyl protons resonate at delta 2.34. So it's telling there is a toluene, the methyl protons resonate at 2.34, whereas the methyl group attached to an acyclic alkene resonates at 1.95. This is the question he has asked in different sense. Here he has asked by giving the structures, but here he is giving the explanation in terms of the question and is asking why it is so. As I said, this toluene, there will be less ring current, and here it is because of the anisotropic effect of the alkene, because of the greater de-shielding influence of the ring current in the aromatic compound. So aromatic compound, they will experience ring current, and hence you will expect more delta value, whereas in the alkene there is no ring current, and hence the delta value will be obviously less. These are some of the problems that you should solve by yourself. Let us see what these problems are. Using n+1 rule, predict the splitting pattern in the following compounds. So predict how many types of signals and the splitting pattern in this compound. Just as an example, I have given this CH3, CH3. For this, the neighbor is CH3, 3 plus 1 is 4, you are going to get as a quartet. For this, the neighbor is CH3, you are going to get as a quartet. Do you get two quartets? Definitely not, because both the CH3s are present in the same environment, and hence you are going to get only one quartet. That is how we have to offer explanation about the splitting pattern of all these compounds. You can take the screenshot of this slide and you can solve by yourself, and if at all there are any doubts, just post it in the discussion forum in my channel. The next question, comment on the number of signals and their splitting, if any, in the following compounds. Again, you have to predict the number of signals in this and you have to predict the splitting pattern, if at all there is any splitting. So here, this is a tertiary butyl group and this is ether type, that is methoxy. So you are going to get one peak for this and one peak for this. So number of signals will be 2, and splitting, this appear as a singlet, this will appear as a singlet, because all the methyl groups are present in the single environment. There is no neighboring proton. 0 plus 1 is 1, that is singlet. For this also 0 plus 1 is 1, that is singlet. And this is TMS, tetramethylsilane. There is no splitting, but there will be only one signal in the compound. So solve by yourself. Let us see the next problem. Explain chemical shift in methoxybenzene and nitrobenzene. Methoxybenzene is C6H5OCH3. So methoxy, it is an electron releasing group. So it will be having the value between 2.5 to 3, whereas benzene will have value between 6.5 to 7. Why 6.5 to 7? Because the methoxy is electron releasing or electron donating group, whereas nitrobenzene, we know that nitro is electron withdrawing, and hence the benzene will be having more, 7.8 or 8 delta value, and hence you can explain these two compounds, methoxybenzene, nitrobenzene, will show different chemical shift value. The next is based on the chemical shift. Calculate the chemical shift in ppm for a proton that has resonance 128 Hz downfield from TMS on a spectrometer that operates at 60 megahertz. We know that chemical shift value can be calculated by using the formula. Chemical shift is equals to number of hertz away from TMS divided by spectrometer frequency into 10 raised to 6. Here 128 divided by 60 into 10 raised to 6 into 10 raised to 6. 10 raised to 6, 10 raised to 6 gets cancelled. 128 by 60, you are going to get approximately 2.1 ppm delta. The next question, the position of OH proton of phenol varies with concentration in solution, but the OH proton of the orthohydroxyacetophenone appears at delta very high, 12.05, and does not show any great shift upon dilution. Explain. The simple reason for this is the hydrogen bonding. That is one of the factors which affect the chemical shift. Here in phenol, upon dilution, the value it varies like anything. Whereas in orthohydroxy acetophenone is benzene ring, COCH3 at ortho position you have OH, and between H and O you will have an hydrogen bonding, and upon dilution, because it is an intramolecular hydrogen bonding, there will be no change in the delta shift upon dilution. Whereas in phenol it shows intermolecular hydrogen bonding, and upon dilution the delta will vary like anything. The next question is, sketch the 1H NMR spectrum of propyl bromide. When such a question is asked, you have to write the structure of the compound. Propyl is 3 carbons, 1, 2, 3, and bromide. You have to see how many different types of signals you are going to get. 3 signals, CH3, CH2, CH2. All the 3 protons are present in different environment, and hence you are going to get 3 different signals. Next, predict the splitting pattern. For this CH3, the neighbor is CH2, 2 plus 1 is 3. That means you are going to get a triplet here. This is CH2, CH3. 3 plus 2, 5. 5 plus 1 is 6. So for this, you are going to get a sextet, or you can say multiplet. For this, the neighbor is 2. 2 plus 1 is 3. Hence, you are going to get triplet. So 2 triplets and 1 sextet. The value will around, this is primary alkyl 0.9. This is secondary alkyl 1.83. And this is bromo attached, hence this is 3.5. So how you can write here on x-axis ppm, on y-axis it is intensity. So around this you have to write a triplet, around this 1.83 you have to write a sextet, and around this 3.5 you have to write a triplet. So this is how we are going to solve the. We'll continue with the next set of problems. Exercise 2. So far you have seen that either a structure would be given or a name of the compound would be given, and asked you to predict the chemical shift, splitting pattern, and the number of signals. In this exercise, we are going to see that a molecular formula will be given, delta value will be given, and the splitting pattern is also given along with the coupling constant value, and finally you have to predict the structure of the compounds based on the given data. Let us see by taking different examples. The first problem is the molecular formula C5H10O. When such a problem is asked, then first thing that you have to do is to calculate the double bond equivalent. That is, how many unsaturations or rings are present in the compound. So for that, you have to make use of CaHbNc. And to calculate the dBe, the formula is A plus 1 plus C minus B by 2. Here, A will be 5, B will be 10, and C will be 1. So if you calculate, the dBe will be 1 for this compound. Let us see what it is. 1 represents 1 unsaturation is present in the molecule. Now, coming to 0.95 delta, we have to take up 1 by 1 value. 0.95, that means it could be a primary alkyl group, 6H doublet. 6H doublet, and J is 7 Hertz. J is coupling constant. It is showing the distance between the two peaks is 7 Hertz. The next value is 2.10, and the splitting pattern is a singlet. It contains 3 protons. The next is the delta value is 2.43. It has got 1 H multiplet, and J is 7 Hertz. So this is J is 7 Hertz. This is also J 7 Hertz. It indicates that these two protons are near by each other. These two are neighbors, whereas this is not present as a neighbor because it is got only a singlet. That means there are no neighboring protons. So doublet, multiplet, 6H, 1H. It clearly tells that it should be an isopropyl group. 3H singlet, it is the characteristic feature of CH3, that is methyl. So we have identified 1 methyl and 1 isopropyl. 1 methyl and 1 isopropyl group. So this is a singlet, and this is doublet and multiplet. Instead of multiplet, you can also write it as septet. So more than 4, we normally write it as multiplet. Then another one we have to satisfy is 1 carbon and 1 oxygen. They are telling that the double bond equivalent is 1 after the calculation. So it should be C double bond O. Therefore, the structure is isopropyl methyl ketone. Now we have to satisfy the splitting pattern, the chemical shift. So it is methyl ketone 2.1. There is no neighboring proton. That's why it is appearing as a singlet. Here CH having 6 protons, 6 plus 1 is 7, that is septet or multiplet. And these two are having the same chemical environment. The neighbor is CH, that is 1. 1 plus 1 is 2. That's why you're going to get a doublet. Doublet at 0.5, multiplet at 2.3, singlet at 2.10. The next problem, C10H14. So if he's telling that there are two kinds of protons, one is 9H, another one is 5H. The first thing that you have to do is to calculate the double bond equivalent. Here the double bond equivalent, it comes to 4. When you calculate and substitute this 10 and 14 in that formula, you will get the double bond equivalent to be 4. 4 usually refers to the presence of a benzene ring. So in benzene, there will be 3 unsaturations, 1, 2, and 3, and ring is also considered as one unsaturation, and hence the dBe is 4, that is satisfied. So 7.3 delta, 5H singlet. 5H, that means in benzene there will be 6 protons, but he is telling 5. So there should be 5 protons, and one of the proton is substituted by some other group, and hence it is called a mono-substituted benzene. The mono-substituted benzene has got delta of 7.3, and usually it appears as a singlet. Another one, 9H singlet. 9H singlet, it is the characteristic feature of tertiary butyl group. This is the tertiary butyl. Butyl means 4, and the middle is carbon surrounded by 3 methyl groups. So these 3 methyl groups, they appear as primary methyl, but attached to aromatic, there will be some amount of ring current influence, and hence instead of 1, you can expect the value to be little higher, 1.3. Whereas this is again a mono-substituted benzene. All the protons are present in the same environment, atmosphere, and hence it appears as a singlet. Another problem, C10H14, these two are the isomers, but look at the delta values. This is different and this is different. We have to check. Again, calculate the dBe for C10H14. The dBe again comes to be 4. That means 3 unsaturation, 1 ring, totally 4 unsaturation. We will see. So he is telling 7.125H singlet. It clearly indicates the presence of a mono-substituted benzene, and 6H, 1H, doublet, multiplet. It is the characteristic feature of a isopropyl group. So we have identified one mono-substituted benzene. We have identified an isopropyl group, and another one 2H doublet. 2H is CH2, and this CH2 should have a neighbor of 1, that is CH. So 1 plus 1 will be 2. That's why it is coming as a doublet. So this is the structure of the compound that meets this requirement. So 0.88 6H doublet. This is 0.88 6H doublet. Why doublet? There is only one neighboring proton. 1 plus 1 is 2. That's why it is doublet. And this is for this proton, 6 plus 1 is 7, septet or multiplet appearing at 1.86. This is methyl attached to benzene ring, aromatic group. That's why it is 2.45. And this is a mono-substituted benzene ring, and hence the delta value will be 7.12 singlet. Another problem, C9H11Br. We have to calculate the dBe for this. If you calculate the dBe, it comes to be 4. That means 3 unsaturation and 1 ring, totally 4 unsaturation. Based on this, now we have to identify what this compound is. The simplest way to analyze this is, see here for 5H singlet. 5H singlet, as I said, it refers to a mono-substituted benzene ring. So put a mono-substituted benzene ring. Now 2H, 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 quintet, triplet, triplet. This is the characteristic feature of propyl group. CH2, CH2, CH2. See here, 2H, 2H, 2H. 2H, 2H, 2H refers to CH2, CH2, CH2. All 3 are present as neighbors because the coupling constant value of the methylene group is 7 Hz, 7 Hz, 7 Hz. So this quintet, that means it should have the neighbor of 2 plus 2. So this should be a middle carbon. This is terminal and this is also terminal, but there is Br and we have to check where you have to put the Br. So the one which have the highest delta value 3.38, there you have to put the bromine. Therefore, the structure is a benzene ring monosubstituted CH2, CH2, CH2. The terminal one will be Br. So Br is an electronegative element, and hence the value of these protons will be 3.38. So it has got a neighbor of 2 protons. 2 plus 1 is 3. It appears as a triplet. And for this, 4 plus 1 is 5. That is quintet. Delta value will be 2.15. For this, the neighbor is 2. 2 plus 1 is 3. It appears as a triplet. And this is methyl benzene time. That's why the value will be 2.75. Coming to the next problem, C4H7BRO, and you have to calculate the DBE. For this, the DBE comes to be 1. That means there is only one unsaturation and there cannot be any ring. See, that is the difference that you should understand. Whenever there is ring, there will be more protons and there will be more carbons. Here, this case and this case. Whereas this case, it cannot be a ring. Here, this case, there cannot be a ring because it is only C4H7, and there are also bromo and oxygen. Let us see what we can do. Simply by observing this, 3H singlet refers to there is a CH3 group without any neighbor, and hence you are going to get a singlet. And there is a hint or clue that these two protons are present as neighbors because they have got the same coupling constant of 6 Hertz. So 2H refers to CH2. Now we have got 3. One is CH3, one is CH2, another one is CH2. This CH2 should be present as neighbor, and hence they are appearing as triplet. Now you have to substitute Br and O. There is one such unsaturation. It indicates that it should be a carbonyl compound. So CH3CO, CH2, Br. And this CH2 has got more value because this is attached directly to the electron withdrawing bromo atom. Next problem, C4H9Br. The DBE for this is 0. That is, there is no unsaturation in this compound. And we will see doublet and multiplet. It indicates the presence of an isopropyl group. This is the isopropyl group, multiplet and doublet. This is CH2. It should be attached to a CH. So CH2 attached to CH. And there is a bromo here. So where the value will be high, you put the bromo there. So Br, CH2, CH, CH3, CH3. Next is C3H3Cl5. In this type of problem, you have to be little more careful for the reason that there are only 3 carbons, 3 hydrogens, more chloro. Now we have to think where we have to put the chloro. He is telling that there will be only one CH, there will be only one CH2. Let us write CH and CH2. So now you satisfy the valency of this carbon. You put 2 chloro and 3 chloro this side. You are going to get the compound. This CH2 has got the delta value of I 6.07 because this is directly coming in contact with 3 chloro groups. As the number of electron withdrawing groups increases, delta value also increases, that we have studied earlier. And whereas this has got only 2 chloro, that's why the value will be only 4.2. This is having a neighbor of 2 protons, 2 plus 1 is 3, that's why it is appearing as a triplet. Whereas this is having a neighbor of only 1 proton, 1 plus 1 is 2, that's why it is appearing as a doublet. Another problem, C3H5Cl3. Don't get confused between these two problems. C3H3Cl5. This is C3H5Cl3. He is telling there are only 2 types of protons. One is CH3, another one is CH2. Both do not have any kind of neighbors, and hence they are appearing as singlet. So write one CH2, another one is CH3. And now you have to satisfy 1 more carbon and 3 chloro. So this 2 should be divided definitely by a carbon, which is substituted by 2 chloro, and the remaining chloro is going here. So this is having no proton neighbor, appearing as a singlet at delta 4.02. This is having no proton as neighbor and hence appearing as a singlet at 2.2, and this is 4.02. Coming to the next problem, C10H13Cl. When there are more number of carbons and hydrogens, you can easily expect the presence of a benzene ring. In this case, let us see 7.275H singlet. It is the characteristic feature of a mono-substituted benzene, and he is telling 6H. 6H always it is CH3 twice, and the CH2 singlet, that is CH2, there is no neighboring proton here. So put a monosubstituted benzene ring, one CH2, CCl, CH3, CH3. And now let us see, by satisfying the values given, monosubstituted 5 protons, 7.27, singlet, CH2, it is appearing as a singlet. Yes, there are no neighboring protons, that's why it is appearing as a singlet. And 3.07, the value is slightly higher than the expected aromatic methyl. Aromatic methyl is usually 2.3 to 2.5, but there is a chloro electron withdrawing. That's why there will be an influence on the delta, and hence the value is slightly more than the expected, that is 3.07. Whereas there are two CH3 groups that you have to put at the end. The value will be slightly higher, 1.57, than the normal one because of the presence of the electron withdrawing chloro group. Coming to the last problem for this exercise, C3H6Cl2. For this C3H6Cl2, the double bond equivalent appears to be 0. He is telling 2.2 quintet, 3.7 triplet. He is not telling how many number of protons are there. It goes without saying that quintet, if at all there is quintet, there should be neighbor CH2 and CH2. In the middle, there should be CH2 because it is appearing as a triplet. So you can definitely write a propyl group CH2, CH2, CH2. 3 hydrogens are satisfied, 3 carbons are satisfied, 6 hydrogens are satisfied. The remaining are 2 chloro. Put one on each end. Cl, Cl. Let us see now. Yes, this CH2 has got only one CH2. 2 plus 1 is 3. That's why it is appearing as a triplet. Triplet is 3.17. Coming to this proton, this is a symmetric molecule, and hence whatever you predict for the LHS, the same will be for the RHS also. So 2, 2 is 4, 4 plus 1 is 5, and hence it is appearing as a quintet at delta 2.2. So this is all about the different types of problem. This is what we have understood in this class about exercise 1 and exercise 2. More problems and composite problems we will see in the next class. Thank you very much.